Hyperion, the largest of Saturn's irregular moons. It tumbles through the void 1.5 million kilometers from its parent planet, spinning with a chaotic motion that makes its future orientation almost impossible to predict. Unlike many of Saturn's other 292 confirmed moons, it isn't smooth and round, but jagged, porous, and irregular, like a giant, frozen cosmic sponge. It's a world that defies almost every conventional rule of planetary science. But why? Voyager found hints of a violent past, a great crater visible from afar. But it wasn't until Cassini explored Hyperion in 2005 that it all became clear. Complex gravitational interactions, ancient proto-moon collisions, and an unusual composition make this, arguably, the strangest place in the Saturn system. Oh, and did I mention it has the power to zap you with electricity from 2,000 kilometers away? Yes, you did hear me right. I'm Alex McColgan and you're watching Astrum. Join me today as we venture 1 billion kilometers from Earth to this extraordinary moon, exploring the violent history of its birth, the maths behind its chaotic motion, and the incredible discovery that Hyperion can dish out electric shocks in space. To understand Hyperion, we first must look back to the mid-19th century, a golden age for observational astronomy, when our understanding of the geography of the solar system skyrocketed thanks to an explosion of tech and precision instruments in the 1840s. With teams all around the world making new discoveries, finding Hyperion was actually not a singular event, but a two-way transatlantic tie. On the evening of the 16th of September 1848, at the Harvard College Observatory, the American father and son team of William and George Bond spotted a faint object that did not appear on any existing charts of the Saturnian satellites. William Cranch Bond was a well-respected astronomer. Whilst he had a lack of formal education, he worked his way up to become the first director of the Harvard Observatory. He was utilizing its new 15-inch equatorial refractor, one of the most powerful instruments in the world at the time, when he and his son first spotted Hyperion. It was just 2 nights later, thousands of kilometers across the Atlantic, that William Lassell, a wealthy British brewer who had turned his fortunes towards the stars, made the same discovery using a 24-inch speculum reflector of his own design. Thankfully, the resulting dispute was less of a conflict and more of a celebration of human ingenuity. Because the observations were so close in time, the astronomical community eventually settled on a rare triple credit discovery, honoring both Bonds and Lassell together. It was soon named following a suggestion by John Herschel, who argued that Saturn's moon should be named after the Titans, the siblings of Kronos in Greek mythology. Hyperion, the titan of watchfulness and observation, was a fitting choice for a moon that, as would be later discovered, never looks the same way twice. In fact, this moon was unusual from the start. It was the first non-spheroid moon to be discovered, and as we learned more, things only got stranger. Hyperion is a world that refuses to be categorized. It's one of the largest bodies in the solar system that's highly irregular in shape, a status it shares only with Neptune's moons Proteus and Nereid. In the hierarchy of Saturn's moons, it's the 8th largest by radius, but curiously only the 9th most massive, a discrepancy that hints at its unusual internal structure. And as we discovered thanks to Voyager data in the 80s, it also rotates chaotically. In fact, while we often think of moons as spherical mini-planets, Hyperion is anything but this. It's a battered, elongated mass that has been compared to everything from a potato, to a burger, to a deflated football. But why exactly is it so strange? One of the most curious things about Hyperion is its density. at approximately 0.54 grams per cubic centimeter, this moon is only about half as dense as liquid water. Even compared to pure water ice, which has a density of roughly 0.92 grams per cubic centimeter, Hyperion is an outlier. This tells us that it cannot be a solid, monolithic block of ice and rock. Instead, it is likely a pile of rubble. If you were to stand on it, the ground beneath your feet would be a fragile, honeycomb lattice of ancient water ice and organic dust. In fact, data from the Cassini mission suggests that more than 40% of Hyperion's interior is just empty space. This high porosity is likely a relic of its formation. Unlike larger moons that underwent differentiation, a process where internal heat melts the interior and allows heavy materials to sink to the core, Hyperion likely never stayed warm enough or long enough to compact its structure. It instead remains a primitive collection of debris, potentially even the reaccreted remains of a much larger proto-Hyperion, measuring perhaps 1,000 kilometers across. A massive collision likely shattered this world, leaving Hyperion as the largest remaining piece. The rest of the debris might have rained down on Titan or been ground into the dust that now forms the dunes of that orange world. More on Titan later. But this internal structure of Hyperion isn't just a window into the past. It also impacts on the moon today. Not only does it give the moon an extremely low escape velocity, in fact a professional baseball player could nearly throw a ball into orbit from Hyperion's surface, but the moon acts as a shock absorber, and this explains Hyperion's rather unusual appearance. When the Cassini spacecraft performed its close flybys of Hyperion in 2005, the images it returned were unlike anything seen before. The surface was covered in deep, sharp-edged pits, making it resemble a wasp's nest or a sea sponge. On a typical solid moon, such as our own, an impacting asteroid strikes the surface at several kilometers per second. The kinetic energy is released in an explosion that creates a crater, blasting material, otherwise known as ejecta, outward to form a rim and a surrounding debris blanket. On Hyperion, the process is fundamentally different. Because the moon is so porous, the impact doesn't blast as much as it compresses. It's like firing a pebble into a block of styrofoam. The material is pushed downward and is compacted, creating a deep hit without the typical rim or ejecta rays. Because Hyperion's gravity is so weak, any material that is kicked up during an impact also has a very high probability of reaching escape velocity. Instead of falling back to the surface to fill in old craters or coat the landscape in a layer of dust, it simply flies off into orbit around Saturn. This leaves the surface clean, preserving the original, crisp and deeply etched shapes of the craters for billions of years. The result is one of the most crater-saturated surfaces in the Saturnian system. They are spectacular to look at. Hyperion really does look like a sponge to me. But they're certainly not the only strange thing this moon has to offer. Hyperion moves like no other body in the solar system. Hyperion does not exist in a vacuum. Its existence is sculpted by its much larger neighbor, Titan. Now, Titan is a behemoth, the second largest moon in the solar system, and its gravitational shadow looms large over everything in its vicinity. Hyperion and Titan are locked in a 4-3 orbital resonance, which means that for every 4 orbits Titan completes around Saturn, Hyperion makes exactly 3. This resonance is a delicate gravitational tug-of-war. As the moons pass each other, Titan's immense gravity gives Hyperion a periodic kick. This interaction has 2 major effects. First up, Titan's gravity prevents Hyperion's orbit from becoming completely circular. Instead, it follows an eccentric, egg-shaped path that brings it closer to and further from Saturn at various points in the orbit. Secondly, The combined influence of Hyperion's irregular, elongated shape and the varying gravitational pulls from Saturn and Titan create a state of dynamical chaos. In most of the solar system, gravity acts like a clock, allowing us to predict the positions and orientations of planets centuries into the future, but not on Hyperion. In 1984, planetary scientist Jack Wisdom and his colleagues at MIT created new mathematical models to predict the motion of Hyperion, trying to explain why it tumbles rather than spinning smoothly. They found that the moon's rotation is so sensitive to its environment that its orientation is unpredictable over timescales as short as a month, a period known as Lyapunov time. In other words, we literally don't know how it's going to spin for more than a few weeks into the future. It is the only large moon in the solar system known to lack a stable spin axis like this, and is one of the first confirmed examples of chaotic motion in the cosmos. If you were to stand on Hyperion, the sun wouldn't rise in the east and set in the west in a predictable pattern. It might zigzag across the sky, move backward, stay stationary for days before suddenly plunging below the horizon. But beyond its physical structure and its erratic movement, Hyperion holds an even deeper secret. One of the most important instruments the Cassini spacecraft was fitted with was the visual and infrared mapping spectrometer. Its job was to map the composition, temperature, and structure of Saturn, and in this case, its moons. When it turned its gaze to Hyperion, it revealed a complex mix of water ice and organic compounds. The bright crater walls are primarily composed of crystalline water ice, similar to what we might find on Earth. However, the dark material at the bottom of the craters is something else entirely. A slurry of hydrocarbons and organic dust. Dale Cruikshank, a planetary scientist at NASA, has pointed out that these hydrocarbons are the same basic chemical building blocks found in comets and meteorites. But where does this dark material come from? To solve this mystery, we must look further out to the moon Phoebe. Phoebe is a dark, retrograde moon that is believed to be a captured object from the Kuiper Belt, the same region that gave us Pluto. I've made a video about it you can watch here if you want to know more. It is also the source of a massive, nearly invisible ring of dust that orbits Saturn. As this dust spirals inward towards the planet, it is intercepted by the other moons. Iapetus, Saturn's yin-yang moon, catches most of this dust on its leading hemisphere, but some of it gets past Iapetus and lands on Hyperion. Because Hyperion is tumbling chaotically, it doesn't have a single leading side, which means the dark material is instead spread more evenly across its surface, though it naturally settles into the low points of the craters. One of the other most intriguing findings was that carbon dioxide on Hyperion is not pure dry ice. Instead, it is chemically complexed or attached to other surface materials. This makes the CO2 more stable, preventing it from evaporating into space even over the 4.5 billion year history of the solar system. The presence of these molecules, especially when exposed to ultraviolet light, can lead to the formation of even more complex molecules of biological significance. While this doesn't mean Hyperion harbors life, it proves that the essential chemistry needed for life is far more widespread in the universe than we once imagined. Now, this is all really interesting and certainly paints a picture of Hyperion being a rather odd place. But there is one discovery that Cassini made that I personally find quite shocking. And it came not from its cameras, but its plasma instruments. Hyperion has no atmosphere, and so it is bombarded by solar radiation and exposed to the harsh environment of Saturn's magnetosphere. It's constantly pelted by a rain of charged particles from the planet's magnetic field. Combined, these cause massive electrostatic charges to build up on the surface, particularly near the moon's terminator, the boundary between day and night. This is similar to the static electricity you experience when rubbing a balloon against your hair but on a planetary scale. And this spelled trouble for Cassini. In 2014, a new analysis of data from a 2005 flyby revealed that Hyperion had actually zapped the Cassini spacecraft with a beam of electrons. At a distance of about 2,000 kilometers above the moon's surface, Cassini passed through the magnetic field lines connected to Hyperion. Briefly, the probe and the moon were magnetically connected, and Cassini received the equivalent of a 200-volt electric shock, roughly the same as sticking your fingers into a plug socket, which you should not do. This was the first time a charged surface has ever been detected on any moon other than our own. Thankfully, the shock didn't damage Cassini, but the discovery has serious implications for future exploration. Static charging can cause dust to levitate and move across a moon's surface, potentially coating instruments and even escaping into space. For future robotic or human explorers, these electrostatic discharges could pose a hazard to sensitive electronics, requiring us to design spacecraft that are immune to the electrical charges of the worlds they visit. So, there we have it. Hyperion shows us that the solar system is far more than a collection of orderly spheres. It is a place of ancient violence, mathematical chaos, and unexpected chemistry. From its bizarre, sponge-like surface that absorbs the impact of the cosmos, to its unpredictable, tumbling rotation that defies our best equations, Hyperion is a world that keeps us humble. The discovery that a small, icy moon can reach out across 2,000 kilometers to zap a visitor from Earth shows just how much we still have to learn about the interaction between celestial bodies and the environments they inhabit. As we continue to gaze out at the ring planet and its diverse family of moons, Hyperion remains one of our most fascinating targets. A world that refuses to sit still, refuses to be predicted, and refuses to be anything other than its own strange, beautiful self. If you enjoyed this deep dive into Hyperion, be sure to subscribe to Astrum for more explorations of our amazing solar system and beyond.